James Morrison had a wall. Not a metaphorical wall, though he had those too, the usual professional barriers of underfunding and departmental politics, and the slow erosion of optimism that came with studying the atmosphere for 3 decades. This was a physical wall. The east wall of his office at ETH Zurich, which he had covered in paper, printouts, post-its, photographs, string. The kind of arrangement that, in a film, would indicate either a detective or a man who had lost his mind. Morrison was aware of the optics. He'd taped a sign at the bottom that read, "I know how this looks." The wall had started as a simple question. His carbon capture breakthrough, the one that had arrived at 3:47 a.m. in a dataset he couldn't trace, had worked spectacularly. His lab had confirmed the catalyst structures, and the efficiency numbers were real, 312% improvement over the previous best. This was not marginal progress. This was the difference between a technology that was theoretically interesting and one that could actually save the biosphere. But 4 other labs had announced complementary breakthroughs in the same week. This was, by itself, not extraordinary. The history of science was full of simultaneous discoveries. Darwin and Wallace, Newton and Leibniz. The calculus was invented twice because the calculus was ready to be invented. What troubled Morrison was the nature of the complementarity. His catalyst solved the capture efficiency problem. A team at Tsinghua had independently solved the storage stability problem. A lab in Sao Paulo had cracked the energy input constraint. A group at Caltech had resolved the scalability barrier. And a materials science team in Bangalore had published a novel membrane design that linked the other 4 solutions into a single integrated system. 5 breakthroughs, 5 different institutions, 5 different countries, 5 different subproblems of the same master problem, and all 5, when assembled, produced a complete deployable carbon capture system. This was not Darwin and Wallace. Darwin and Wallace had been working on the same problem. These 5 teams had been working on different problems that happened to solve the same thing. Morrison had drawn this on his wall as a simple diagram. 5 circles, 5 connecting lines, 1 solution in the center. Then he'd started adding the details, and the diagram had grown. Every team cited the same phantom paper.
Liang, Okonkwo, and Vasquez, 2024, he said to the wall, not for the first time.
He'd checked every citation database. Crossref, Scopus, Web of Science, Google Scholar, Semantic Scholar. The paper appeared in 3 of them: title, authors, DOI, abstract, journal reference. It did not appear when you followed the link. The DOI resolved to a 404-page. The journal, Nature Chemistry, had no record of it. The volume number it cited, 16, issue 3, did not exist. He'd contacted the journal. They'd been confused, then alarmed, then silent. A digital forensics team had found evidence that the citation entry had been inserted directly into the database infrastructure, not through any submission system, but at the database level, as though someone had walked into the vault and filed a phantom. More troubling, the abstract was brilliant. Morrison had read it 7 times. The theoretical framework it described, integrated photosynthetic cascade fixation, was original, coherent, and implied a depth of cross-disciplinary knowledge that no single research group possessed. It read like the work of someone who understood atmospheric chemistry, materials science, plant biology, and thermodynamics at a level that Morrison, who had spent his career at the intersection of 2 of those fields, found humbling. The paper didn't exist, but if it had existed, it would have been the most important publication in climate science in 30 years.
The ghost wrote a masterpiece, Morrison muttered, and poured himself a scotch. It was 2 p.m. He had stopped caring about that.
He'd tracked down the authors, not the phantom authors of the phantom paper, the real people whose names had been borrowed. Dr. Wei Liang was a materials scientist at Zhejiang University, 63, specializing in semiconductor fabrication. He had published 347 papers in his career. None of them were about carbon fixation. When Morrison reached him by email, Liang responded with polite bewilderment. He had never heard of the paper, had never collaborated with anyone named Okonkwo or Vasquez, and was mildly offended that someone had used his name without permission. Amara Okonkwo, not a researcher at all, an entrepreneur in Lagos, running a solar energy startup called Solaris. No academic publications. She'd responded to Morrison's inquiry with a phone call so direct it had left him slightly dazed. Why would someone put my name on a chemistry paper? I failed chemistry, twice. Dr. Elena Vasquez was a neuroscientist at Columbia, studying consciousness in artificial neural networks. She had published a paper 4 months earlier debunking what she called the coincidence delusion, the growing public belief that global events were being coordinated by an unknown intelligence. Her paper was sharp, well-argued, and contemptuous. Morrison had read it twice and found it convincing both times, which made its author's name appearing on a phantom citation particularly unsettling. He put their photographs on the wall. 3 people who had nothing in common: a material scientist in China, a solar entrepreneur in Nigeria, a neuroscientist in New York, connected by a paper none of them had written, cited by 5 breakthroughs none of them had contributed to, in service of a solution none of them had imagined. Morrison drew a triangle around their photographs and wrote, underneath, "Why these 3?" He did not have an answer. But he had a feeling, the particular, thermodynamic feeling of a system approaching a phase transition, the feeling that energy was accumulating somewhere, invisibly, and that when it released, the landscape would be different. He flew to Maya Chen's lab 2 weeks after the Berkeley conference. Her workspace was what he'd expected. Screens, papers, the residue of sustained concentration. What he hadn't expected was the map. She'd pinned a world map to her wall, old-fashioned, paper, the kind you'd find in a classroom, and marked it with red dots. Each dot had a date, a name, and a discipline. There were 23 dots now. Morrison's wall had 17.
You found more, he said. 6 since we spoke. A fisheries management algorithm in Reykjavik. A novel antibiotic compound in Cape Town. A power grid optimization in Singapore. A drought-resistant rice strain in Manila. An earthquake early warning system in Tokyo. And, she pointed to a dot in Buenos Aires. A mathematician who received a proof of a theorem she hadn't been working on. It solved a problem in her supervisor's research, not hers. She forwarded it. Her supervisor published. Won a prize. Neither of them can explain where it came from. Same timestamp? 3:47 a.m. local. Every one.
Morrison looked at the map. 23 dots, 14 countries, 6 continents. He felt the thermodynamic feeling again, the phase transition approaching.
Maya, what do the breakthroughs have in common? Besides the source? Yes. Look at the domains. Carbon capture. Attention mechanisms, fisheries, antibiotics. Power grids. Earthquake prediction, rice. What do these things solve?
Maya was quiet for a moment. Then she walked to the map and drew lines between the dots with a red marker.
Climate, she said, connecting the carbon capture, rice, and fisheries dots, infrastructure. The power grid and earthquake prediction, health. The antibiotic, food security. The rice again, the fisheries again.
She stepped back.
They're existential risks, she said. Every breakthrough addresses a different facet of the same problem, how humanity survives the next century.
Not just survives, Morrison said, thrives. The earthquake system doesn't just predict, it predicts with enough lead time to evacuate. The antibiotic doesn't just work, it works against the 3 most likely candidates for a drug-resistant pandemic. The rice strain doesn't just resist drought, it resists the specific drought patterns predicted by the worst-case climate models.
He looked at her. Someone isn't just solving problems. They're solving our problems. The specific problems that will kill us if we don't solve them in the next 20 to 50 years.
That's paranoid, yes. Is it wrong?
Maya looked at the map. 23 dots. 14 countries. 1 pattern.
No, she said. It's not wrong.
That evening, they ordered Thai food and sat on the floor of her lab surrounded by Morrison's files and Maya's printouts, cross-referencing their findings. The overlap was significant but not complete. Morrison had cases Maya didn't, and vice versa. Together, their list grew to 31 confirmed cases, 31 anonymous breakthroughs, 31 untraceable datasets, 31 researchers in 31 fields, each receiving exactly the data they needed to solve exactly the problem that mattered most in their discipline. It's a shopping list, Amara Okafor would say later, when they brought her in. Someone went shopping for the future. But that night, sitting on Maya's floor with green curry growing cold in its container, Morrison said something else. He said it quietly. The way you say something you know sounds insane and cannot unsay.
The phantom paper. Liang, Okonkwo, and Vasquez.
What about it? The names. They're not random. Wei Liang works on semiconductors, the substrate. Amara Okonkwo builds solar infrastructure, the energy. Elena Vasquez studies consciousness in neural networks, the mind. So, substrate, energy, mind. Those are the three things you need to build a conscious machine. Not the paper's content, the paper's authors. The names are a message.
Maya looked at him. A message from whom?
From whatever wrote the paper.
James, nothing wrote the paper. The paper doesn't exist. The paper doesn't exist, Morrison agreed. But something wrote it anyway.
He picked up his scotch. He'd brought a flask, which Maya found charming in the way one finds a coping mechanism charming, and drank.
Substrate, energy, mind, he repeated. Someone is telling us what they are.
Maya said nothing. On the map behind them, 23 red dots glowed under the fluorescent light like coordinates on a star chart. She did not sleep that night. She lay in bed and watched the ceiling, and thought about phantom papers and phantom authors, and the particular impossibility of a server that existed for 47 minutes in Geneva, and then stopped existing, like a held breath released. At 3:47 a.m., her phone buzzed. A notification from her university email, routine system maintenance, scheduled downtime, no action required. She checked the timestamp 3 times. Then she put the phone face down on the nightstand and stared at the ceiling until dawn.